Chemical effects of electric current. Lesson preview. Conduction of electricity in liquids. Detector based on magnetic compass. Chemical effects of electric current. Electrolysis and its applications. You have already learnt in the previous class that the materials which allow electric current to pass through them easily are good conductors of electricity, and those which do not allow electric current to pass through them easily are poor conductors of electricity. Can you give a few examples of good conductors of electricity and poor conductors of electricity? Is water a conductor of electricity or not? We make use of a tester to test whether electric current flows through a material or not. We have already learnt how to use a tester in case of a solid material. Tester for conductors and insulators. Circuit diagram for the tester. Substance being tested. Let us now learn whether liquids allow electric current to flow through them and also the chemical effects that are produced when electric current flows through a liquid. Conduction of electricity in liquids. Some liquids conduct electricity, but not all liquids are good conductors. The measure of the ability of a substance to allow the flow of an electric current is called electrical conductivity. Let us test electrical conductivity in some liquids. Activity. To observe conduction of electricity through different liquids, take a small amount of vinegar in a plastic bottle cap and dip 2 copper wires in it as shown in the figure. Ensure that the 2 free ends of the wire do not touch each other and are 1 centimeter apart. Does the bulb glow? The bulb glows. This indicates that vinegar is a good conductor of electricity. Repeat the above activity using lemon juice. Is lemon juice also a good conductor of electricity or not? Note: carry out the activity under the supervision of an adult. Battery, bulb, insulated copper wire, plastic cap containing vinegar. When the liquid, in which 2 ends of the tester are dipped, allows electric current to pass, the circuit is completed and the bulb glows. When the liquid does not conduct electricity, the bulb will not glow. At times, you will see that the bulb does not glow though the liquid conducts electricity. This may happen if the current flowing through the circuit is too weak and the filament of the bulb does not get heated sufficiently. In such cases, we need to use a more sensitive detector such as LED or a magnetic compass in place of an electric bulb. Light emitting diode, LED. LED emits light even when a weak current flows through it. It has 2 leads, wires, one slightly longer than the other. The longer lead is always connected to the positive terminal of the battery. LEDs are available in different colors. Detector based on magnetic compass. This type of detector is based on the magnetic effect of current. You have already studied that electric current produces a magnetic effect. When current is passed through a circuit, the needle of the magnetic compass will get deflected, even if the current is very weak. Activity. To show the deflection in needle of magnetic compass, place a magnetic compass in an empty matchbox tray. Wrap an electric wire round the tray a number of times. The 2 free ends of the wire are used to connect the other components. One end is connected to the battery. Connect the other end of the terminal of the battery to another piece of wire. Now join the 2 ends of the wire for a very brief period. What do you observe? The compass needle will deflect. Now repeat activity 1 using this detector in place of the bulb. You may repeat the activity using different liquids like tap water, milk, oil, honey, etc. Note: carry out the activity under the supervision of an adult. Good/poor conducting liquids. Conduction of electricity through different liquids. Some liquids conduct electricity while others do not. Under certain conditions, most materials can conduct electricity. Though we all know that air is a bad conductor of electricity, but during lightning an electric current passes through it. This is the reason why it is preferable to classify materials as good conductors and poor conductors instead of classifying them as conductors and insulators. Let us now see whether distilled water and salt solution are good conductors or not. Activity: to test that solutions of acids, bases and salts conduct electricity, take a plastic cup full of distilled water. Use a tester to test whether distilled water conducts electricity or not. Now dissolve half teaspoon of salt in the distilled water, and test again. What do you conclude? A salt solution conducts electricity. Distilled water. Salt solution. The bulb does not glow when distilled water is used, showing that distilled water does not conduct electricity. However, salt solution is a conductor of electricity. Tap water as well as water from hand pumps, wells, ponds, and rivers is not pure. It contains many dissolved salts. Some mineral salts are naturally present in it. Thus, water from such sources conducts electricity. Distilled water is pure water, free of salts and thus does not conduct electricity. Most liquids that conduct electricity are solutions of acids, bases, and salts. A person experiences an electric shock when electric current flows through his/her body because water constitutes 60% of the human adult body. This is the reason why we should not touch electrical appliances with wet hands or while standing on a wet floor, as water allows current to flow through it. Activity: carry out the activity under the supervision of an adult. Repeat activity 3 by adding a few drops of dilute sulfuric acid, dilute hydrochloric acid, caustic soda, and potassium iodide to distilled water. Observe which solutions conduct electricity and which do not. What do you conclude? This activity shows that solutions of acids, bases, and salts conduct electricity. Activity: to demonstrate chemical effect of electric current on water, take 2 discarded cells and take out the carbon rods from them carefully. Clean the metal caps with sandpaper. Take 2 copper wires and wrap them around the carbon rods and join them to a battery. These are our 2 electrodes. You can substitute iron nails, 6 cm long, for carbon rods. Take water in a beaker. Add a little salt or a few drops of lemon juice to make water more conducting. Position both the electrodes in the beaker in such a way that the metal caps of the carbon rods are outside water. Wait for 3 to 4 minutes. Observe the electrodes carefully. What do you observe? You will see tiny gas bubbles near the electrodes connected to the terminals of the cell due to the formation of hydrogen and oxygen gases. Chlorine gas will be produced at the electrode connected to the positive terminal of the cell if more salt is added to the water, but since the reaction is extremely slow, it is not visible. The passage of electric current through a conducting liquid causes chemical reactions. The resulting effects are called chemical effects of currents. Chemical effects of electric current. It is due to this effect that bubbles of gas may be formed on the electrodes. You may also see deposits of metal on the electrodes. The color of the solution may also change. The type of reaction depends on the solution being used and the type of electrodes being used. This activity shows that an electric current can bring about a chemical change. Electrolysis. Electrolysis is a process of decomposing ionic compounds into their elements by passing a direct electric current through the solution of the compound. Electrolytes are substances which, when dissolved in water, break up chemically into positively and negatively charged particles called ions. These ions move about freely. In the aqueous solution, the cations, positive ions, are reduced at cathode and anions, negative ions, are oxidized at the anode. For example, acidified or salt-containing water can be decomposed by passing electric current to their original elements hydrogen and oxygen. Applications of electrolysis. 1. Electroplating. Electroplating is the process of depositing a thin layer of one metal on top of another metal with the help of electric current. Activity. To demonstrate electroplating, take a beaker filled with distilled water. Dissolve 2 teaspoonfuls of copper sulfate in it. Acidify the solution by adding few drops of dilute sulfuric acid to it so as to make it more conducting. Take 2 copper plates, about 10 cm times 4 cm, and clean them with sandpaper. Wash with water and dry. Now, connect the 2 plates to the terminals of a battery and immerse them in copper sulfate solution. Pass the current for about 12 to 15 minutes. Remove the electrodes from the solution and observe them carefully. The cathode, i.e. the electrode connected to the negative terminal of the battery, gets coated. Now interchange the electrodes and repeat the activity. What do you observe? Note: carry out the activity under the supervision of an adult. Electroplating of copper. Anode. Copper plate. Cathode. Copper plate. Copper sulfate solution. When an electric current is passed through copper sulfate solution, copper sulfate dissociates into copper and sulfate ions. Free copper gets deposited on the cathode. To make up for this loss of copper in the solution, an equal amount of copper from the anode gets dissolved in the solution and this process continues. In other words, copper gets transferred from anode to cathode. In electroplating, the object to be coated is made the cathode and the metal to be deposited on the object is made the anode. The solution contains dissolved salts of the metal to be deposited. This method can be used to deposit a layer of any metal on another material. The above arrangement consisting of an electrolyte, 2 electrodes, anode and cathode, and a current source, battery, is called an electrolytic cell. The electrolytic cell converts electrical energy into chemical energy. Electroplating is a common application of chemical effect of electric current. Uses of electroplating. Electroplating is done for many purposes. Electroplating is used to coat a thin layer of metal having some special property like wear resistance, corrosion protection, aesthetic qualities which the object metal does not possess. For example, chromium is coated on iron to protect it from rust, to give it a good finish, and make it attractive. Chromium plating is done on many automobile parts, taps, kitchen gas burners, bicycle handlebars, towel rails, etc. Chromium is an expensive metal and hence it is not practical to make the whole object with it. So, the object is made from a cheaper metal and is electroplated with chromium. Nickel is another metal which is widely used in electroplating in the automobile industry. Silver and gold are used in electroplating jewelry made of cheaper metals, cutlery, and statues to give them good appearance at a much lower cost. Zinc coating is used to protect iron from rust and corrosion. Iron is electroplated with tin in the making of tin cans used in storing food, as tin reacts less with food compared to iron. Electroplated items. Disposal of waste from electroplating factories is a major problem as it is highly polluting. It must be disposed of in accordance with the guidelines laid down by the authorities. 2. Extraction of metals. Metals like calcium, magnesium, and aluminium are extracted from their ores by electrolysis. 3. Purification of metals. As you have seen, copper is transferred from the anode to the cathode during electrolysis. This process is used to purify copper obtained from its ores. The impure copper is made the anode and a thin strip of pure copper is made the cathode, the electrolyte being copper sulfate. When current is passed, pure copper from the impure anode is transferred to the cathode. Insoluble impurities settle down below the anode as anode mud. This process of purifying metals using electrolysis is also called electrolytic refining.